Hello everyone. So now we will see some of the basic terminologies related to database management system. So starting with what exactly is this data, what exactly is this record and tables. So first we will see what is data. What do I mean by data? So data is nothing but any fact, figure or statistics having no particular meaning. Okay. So examples that we could discuss is one. Now what is one? We are not aware of that. So 1 is a number that we know, but the meaning of this 1 is not available. What is ABC? It is a text. 19, again it is a number, but we are not able to say that what exactly the meaning of this 1 or ABC or 19. What exactly is the record then? The next concept is about record. So record is nothing but collection of related data items. So whatever datas are available, it is a collection of that. And for example, in this above example, these three data items has no meaning, but we could see this in this following way, in which you can see one tabular approach where one is called as roll number, ABC is called as name, and age is 19. So now this 19, ABC, 1 are having some meaning. So this one particular row is called as one record. So I hope you are clear with what exactly is this data. Data is meaningless. Any fact, figure and statistics is there, but record is this particular row and has some meaning. Now let us see, looking at the similar kind of table that we have seen earlier. It has columns as well as rows, but in database language these columns are called as fields or attributes or domains, but and these rows are called as tuples or records. So you can see that there are four tuples or records in this particular table, and in this particular you can say uh, table there are total three fields or attributes or domains. Okay. Now what are the examples of data? So examples of data could be there are n number of data requirements are there in the manufacturing industry or any type of industry. It includes employee records, students records, marketing surveys, production data, attendance records, employees attendance records of the employees, salary details of the employees, data from processes, customers data, NC part programs, bill of material. So there are variety of data I can see, and every industry you have visited some of the industries, you are aware of industries, and every industries will be requiring huge amount of data, and some of the examples are mentioned here. Now let us see in manufacturing industry where this data will be required. So that data will be required, for example, if the your senior is asking you that, okay, what was the serial number of that bracket which was faulty? Okay, so you will be telling them that, okay, that serial number of the faulty bracket is 235690. So that kind of data you are sharing. So there are many data requirements in the manufacturing companies. I have given some of the examples. So these examples could be, when is the scheduled maintenance of the machine number 32 is due? Last year's product ABC, it has contributed 16% of the company's profit. So again, this is the data. How many days was the Joe was absent last quarter? So absenteeism record. Similarly, such kind of records are there for the students also. We can see what was the attendance percentage in the last semester. It is available. The orders of the 1000 units of XYZ bearing is due on shipment on the last day of week number 48. So at the end of week number 48, we have to deliver 1000 units of XYZ bearing. So XYZ bearing 1000 units, shipment date or week number 48. These are all examples of data. So what is shear stress of gray cast iron? What is appropriate cutting speed of the machining of a new ceramic part? It could be 756 rpm, but all these data will be stored into the factory somewhere, and we are utilizing this data for various purposes. So that could be the data requirements and manufacturing companies. There are many other requirements also, so each section each department of the company is requiring different types of data. That could be production department, that could be quality department, that could be purchase department, that could be finance department, that could be HR department. So every department is asking for different types of data, and some of the examples are listed over here, and that shows that it is required every day in a huge number. So data requirements are very high in the industry, and they are required very frequently. So datas and databases. So we are representing the data that we have seen. What was the data earlier? So we are revisiting the definition of data, and then they will move towards definition of database. So data means a known fact which gives information, and it may be organization, variety of data required in running in operations in an organization. So this data stored in proper format, this particular style of a format is called as database. So we are arranging this data into number of tables, or we have seen one of the arrangement which is called as table. So this data will be arranged in some particular format in a particular style, and then it is called as database. So database is integrated with different manufacturing functions, design production functions in computer integrated manufacturing, and this is basic requirement of SIM. So databases are one of the basic requirement of computer integrated manufacturing, that is CIM. So electronic and optical database facilities, feeding, storing, retrieval large amount of data is one of the, you can say, characteristics of any system with which is computer integrated kind of system. So data requirements in SIM, there are huge data required. We have just now seen that it could be a machine's data, it could be the operator's data, it could be tools related information, it could be about production status, how many jobs are completed, how many jobs are not yet completed, how many jobs are in process. So that kind of data. Process planning type of data. So what is the operation number 1, operation number 2, operation number 3, and something like that. It could be about material handling data. So where the product A will you can say travel from machine number 1, so which is the next destination, is it machine number 3 or is it machine number 2? So those kind of material handling kind of data. It could be about scheduling data. What do I mean by scheduling? Which job will be manufactured first, which is second number, which is third number. So what is the sequence of manufacturing as far as the jobs are concerned. Then you can say operations of the data. So operations of the data, nothing but you can say what are the different operations we have to perform, what is the material required for this particular material, and many more. So there are many types of data are required in computer integrated manufacturing, and by which we can make some classification of these kind of data. So let us understand what is this classification of the data. So the data could be based on the nature of the data. We can classify it as a static data or dynamic data. Now let us understand what is static data. Static data doesn't changes with the time. Okay, so and dynamic data changes with the time. So what is the static data? So I will give you some example. For example, company's address, company's name, company's GST number, company's maybe different references. These are not changing with the time. So once you are storing this into the database, it will remain till company is there on that particular address, or you can say company is registered with the GST. So these things will not change, and this kind of data can be called as static data. So whenever I will be storing this data, I will not be required to change this particular data. So that is static data. The second data is dynamic data. So what exactly is this dynamic data? So dynamic data changes with time. So I will give you some examples. For example, what is the revenue collection for this particular month till date, or you can say what is the order book status, how many orders are received. So every day, every seconds, for example, some of the e-commerce sites are getting you can say orders, many thousands of orders for every seconds. So for every seconds this data is changing. Some of the companies will be receiving such kind of orders every week or every day or every month also. So that could be any frequency could be there, but this data is changing with respect to time. So similar kind of data is called as dynamic data. Similarly, revenue kind of data, where different checks are coming, different types of payments are made to the company, and that is why it is continuously changing kind of data. Or you can say bank balance. So you are making some expenditure, you are receiving some money into the bank account of the company, and the bank balance is changing. So this is all, this kind of data is called as dynamic data, where the static data is data which is not changing with the time. So that is about nature of the data. The second type of data is storage of the data. So storage of the data is nothing but whether that data is permanent data or temporary data. So for example, product specifications are a permanent kind of data. So once it is finalized, you can store it into the you can say databases, and it will be a kind of permanently stored into databases. Some of the data is not stored permanently because it is not required after a particular time. So one of the example could be the schedule that is made. So we are making production schedule before the shift begin. So for example, my shift is from morning 8 to 4. In that case, whatever on earlier day or in earlier week, whatever schedule I have made, that I have to manufacture, suppose 10 components of product A, and suppose 30 components of product B, then that schedule will not be valid at 4 o'clock when shift is getting over. So I will be following completely different type of schedule after that shift is over. So this particular data can be called as temporary data, or you can say production status. So one of the product could be yet to produce, maybe in process getting produced, or it is finished, or dispatched, or delivered. So these could be the statuses of the product that we are using, and that status is changing continuously. So no need to store that status permanently, as it is changing very quickly into the databases. So it is a temporary kind of data. That is second type of data. And then based on the collected areas of the data, in which areas you are collecting this particular data, that could be product data. So if you are collecting it from design department, the production data is collected from the production. Operations data are collected from the, again, the operations list that you have. And then resource data, resources could be the man, machine, or money, finances. So these could be the different resources which are required to run a company, and data related to those kind of resource, their utilization, their you can say availability, their you can say what is the future availability, and all those things. Then these are called as resource type of data. So these are the three broad ways of classifying data. There are many other ways of classifying data also, but we are right now discussing these three types of classifications of the data. Sources of the data. So if I see the sources of the data, it could be two major sources of data. One is internal and one is external. Now when I call it as a internal source of data, it is nothing but you can say the data which is available with the company. So the data which is available inside the company, it is generally called as free of cost. The reason is the although it is generated by the employees and you are paying it to the employees, but whatever data which company has, which is available at the free of cost. So for example, the data that we have discussed earlier, that okay, what is the serial number of the faulty bracket. So that number is, it is a free of cost. Nobody is going to charge for tailing that particular data. So it is free of cost. It could be in hard copy or soft copy, and all kind of factory data can be called as internal source of data. So whatever is available into the factory, we are calling it as an internal source of data. And external source of data is the data which you would like to take it outside of the organization. So that could be free or paid. Some of the data is available freely, some of the data is available on paid basis. So what are these examples? That could be books, encyclopedia, handbooks, journals, Some of the journals are paid journals and some of the journals are open source or free journals, where you will be downloading directly. uh, there could be some drawings, there could be some prototypes. uh, Again, the patent information, some of the information could be freely available, some of the information could be copyrighted and you have to pay royalty to it and to buy it. And some of the data from the handbooks or the books, it could be in a hard form and you would like to digitize this particular data. So the external data, you will be digitizing it and utilizing it. So that is called as sources of data. Okay, so these are external sources of data. So there is one more source of the data, it is called as data that are generated with the help of reverse engineering. So what do I mean by reverse engineering? Suppose there are some existing product in the market, you will be buying that product, and that product is, suppose whatever process that is followed to develop that particular product, that means from you can say process number 1 to process number 10, you are going in a reverse direction, that means 10 to 1. That is why it is called as reverse engineering. So some of the companies, some of the countries are specifically good at these things, and that is why you can see that if some good product is available in the market, some people will copy it quickly with the same features, with the same aesthetics, and these will be available to you at the cheaper cost, because the development cost will be lesser as it is reverse engineered. Okay, so this is also one source of data that can be used. So this is about different sources of data. Now let us revisit the concept or definition of database. Let us try to understand the concept or definition of the database. The database can be defined as collection of data in a single location in particular format, designed to be used by different users for variety of operations or applications. Let us try to understand, let us break this database definition, and let us try to understand what we wanted to say or what is exactly the database. Look at the first line. The database can be defined as a collection of data in a single location. So it is a collection of data. We have seen that some of the examples of data in at the start of this particular lecture, and then we have seen that this is a collection of data, but it is available at single location. So it could be a server, it could be a cloud in a particular format. So it has some format associated, it could be a tabular format or it could be any other type of format, and designed to be used by different users different users for variety of operations or applications. So this particular database is designed to be used by different users. So what do I mean by different users? It could be different departments, it could be design department, it could be production department, it could be stores department, it could be finance department, it could be a marketing department, and all these different users are using the same database which is available at single location for variety of operations. So for example, the production data will be checked by marketing people for communicating when is the delivery or what is the earliest kind of delivery that we can make, for example, whatever production data is there, that will be checked by quality team for suggesting some design changes into the production design. So design department will be looking at those kind of dimensions or the data which is shared by quality department for making upcoming enhancement into the product. So all are looking at one particular data for by different purpose. Okay, so this is a kind of database which is a collection in a single location. Okay, let us go ahead. The DBMS models. So DBMS models are hierarchical structures or network structures or relational structures. So it is models are nothing but how you are arranging the data available into the databases, and every model or every structure is having some advantages or limitations with the kind of structure that they are following in here. So let us understand these three types of models, how they are behaving, what are their pros and cons in detail, and then we can sum it up for this particular topic. So a hierarchical structure model, are having two types. You can see that this is one parent available. It has two child number one, child number two. Again, this child is a parent for two different childs, and this particular child is a parent for one particular child. And suppose I will give you one example. Suppose there is some information with this particular child, and this first child wanted to access information from this particular child. So how he will be getting that particular information? So he will be requesting it to the parent will request it to their parent. Again, this information will be requested to this particular child, and then it will be received, the request will be received to this particular child. This child will give that information in a same order, this to this, again this child to parent, parent to again child, child to again child. So the same path will be followed again back for you can say communicating that particular information. So the what are the advantages? It is very simple to understand where which information is kept, and based on that we can very easily fetch the information, like for example, whatever information this child wanted to have, it is very easy to fetch from because most of the information will be fetched from this particular parent only. So this is very easy to operate, or this is very easy to understand. The complexity is very less. But on the other hand, the data traffic will be huge, because whatever datas are there, that will be followed by very longer way is used. So this to this, this to this, this to this, this to this, there is no straight connectivity between the devices. And this could be the disadvantage, that the data that is required to be fetched will be fetched slightly delayed, and unnecessary you can say interactions can be found into this kind of hierarchical structure of the model. Now let us look at second type of model, that is network structure model. So in this network structure model, you can see that all the different nodes are connected with each other like this, and you can have some more connections also. For example, this child can be connected to this parent as well, this child can be connected to this particular parent as well. So all the nodes which are required to be connected can be connected directly to those kind of nodes, and they can fetch the information directly. So whatever disadvantage that was there in case of last case, that was you can say hierarchical model, this will be the advantage over here, that we are fetching it very quickly. But the disadvantage is if this model is complex, or you can say a number of you can say child and parent components are more, then in that case it will be a complex system. So who is connected to whom and who is not connected to whom, and it will be a complex network structure. So it is very zigzag kind of lines that will be plotted over there, and understanding this structure will be difficult part. So the understanding simplicity will not be there, but the advantage could be it will be a quicker access to the you can say network you can say nodes. So this is network type of model. And last is relational model, which is most widely kind of used model, in which you can see that there are two you can say tables. One is employee table and another is departmental table. And suppose we'll discuss one example. Suppose what is the you can say uh, what is the where is the location of Weber, suppose. So I can see that Weber is an employee over here, and the employee is working into department number A. Okay, so I will be looking into this departmental table, and I can check that department A is finance department and is located into New York. So in that case I can say that the Weber is working in New York. Similarly, I can say that how many employees are there in say that sales department. Okay, so I can see that in sales department is the department number C, and there is only one department C entry into employee table, and I can say that Brown is the only employee of C department. Okay, so very much similar to that, if such kind of tables are available, I can easily answer these kind of questions. And the reason behind it is relational model. Now why it is called as relational model? So in the informations that we have seen that these two tables are in relation with each other. And how they are related? Due to one of the common column between them. So I can say that this is department number is the available into this employee table also, and this department number column is available in this department table column also. So as one column is common, I can relate all the information of this particular table to this department table information. Okay, so this is how these two columns are in relation. These two tables are in relation. So similarly, I can prepare a database with multiple tables. It could be hundreds of tables or thousands of tables, and by keeping some of the columns as a common columns, I will be establishing relationship between those tables. So these kind of columns are actually, in database terminology, they are called as foreign key, and this column is called as department number column is called as primary key. So we are not getting into that kind of detail, but our agenda is to understand what is exactly the relational kind of model. It is most widely used model, I can say. Almost 90% or more than that databases are of relational type of model, and the reason is this only: I can extend any number of tables, I can extend any number of columns into the you can say table, and it can be observed that by using such kind of columns available, I can really work on this kind of, it is easy to understand. So whatever advantages were there, easy to fetch information and all those things. So the advantages of relational model as well as hierarchical models can be combined over here, and it is very easy to understand, it is easy to extend, is it easy to you can say fetch information, and relatively easier or quicker information can be fetched using this particular relational model. So that's it with the third model. So quickly summarizing what we have studied right now, it is about data, its records, tables, what are the example of data, what is the classification of the data, what are the different sources of data, what exactly is the databases. We have seen the definition of databases, and then we have seen three DBMS models, and which are nothing but hierarchical, relational, and network kind of model. So with this, we will stop today. Thank you very much.